Okay, guys, for today we are looking at properties of exponents. We're going to start with multiplying and dividing powers with like bases, okay? So what we're going to start here is, what is a power, okay? It means it's repeated multiplication. So B here is representing what's called our base. What our base is in math is the number multiplied by itself, okay? So B is representing our base, and our X up here, that is representing our exponent. How many times the base is multiplied by itself, okay? So B is the base, and this exponent is telling us how many times we're going to multiply our base by itself. Okay, so let's take a look at this. So multiplying powers with the same base. We want to write it as repeated multiplication. Okay, so I have 2 to the third power times 2 to the second power. When we write that out, 2 to the third power is in blue here, right? I'm taking 2 times itself 3 times. 1, 2, 3. Okay, 2 to the second power, I'm going to write out 2 times itself twice. Well, if I look at this here, I have 2 times 2 times 2 times 2 times 2, right? Simplifying this, we can write it as 2 to the fifth power, okay? So what we're looking at here is 2 to the third times 2 to the second actually gives us 2 to the fifth, because when we write it out as repeated multiplication, we notice that we're actually multiplying our base by itself 5 total times, okay? So looking at the next one, I have x to the fifth times x to the fourth. Again, I'm going to write it out as repeated multiplication. X to the fifth is x times itself 5 times, and x to the fourth is x times itself 4 times. When I write this out in a simplified form, I notice that it's x to the ninth power, right? There are 9 total x's here, okay? And I'm multiplying them all, so I would have x to the ninth power. Okay, so hopefully we're kind of picking up on a little bit of a pattern here that we notice with our multiplying powers with the same base in our simplified form, right? Okay, so looking at our last one, I have y times y to the sixth. If there's no exponent here, we can assume it's raised to the first power. There's a 1 there, right? So if I write y just once, and then y to the sixth, I write out 6 more y's. Again, when I simplify this, I end up with y to the seventh power, okay? So hopefully we're noticing something about when we're multiplying powers with the same base. Remember, our base has to be the same here. Our base here is 2. Our base here is x, and our base here is y, okay? So when we're multiplying powers with the same base, our rule is a to the n power times a to the m power is equal to a to the n plus m power. Okay, so if we go back and look, 2 to the third times 2 to the second, 3 plus 2 is 5. X to the fifth times x to the fourth, they have the same base. 5 plus 4 is 9. Y to the first times y to the sixth, 1 plus 6 is 7. Okay, that's what our rule here is telling us on this page. A to the n times a to the m is equal to a to the n plus m. Okay, now dividing powers with the same base. Again, we're going to write this out as repeated multiplication. 4 to the seventh power, there's 7 4s up top, divided by 4 to the second power. 2 4s, on bottom. Now when I can simplify this, we notice that I can cross out 2 of these 4s, right? Because 4 divided by 4 is just 1, and this 4 divided by this 4 is also just 1. Well, what am I left with here? I'm left with 5 4s. 1, 2, 3, 4, 5. So 4 to the fifth power. Okay? 4 to the fifth power. For the next one, I have a to the fifth over a to the third. Okay? I have 5 a's up top and 3 a's down below. Again, I can cross these out, right? A divided by a is 1. This a divided by that a is 1. And that a divided by that a is 1. And I'm left with 2 a's, so a to the second power. Okay? Looking at this one's a little different, right? Now we have 2 different kinds of bases here. We have x and y both in the numerator, the top part of the fraction, and the denominator, the bottom part. Okay? So I have 8 x's up top, 3 y's up top, 4 x's down below, and 1 y down below. Okay? So if you notice, we only had to cross out a few things in these first 2. Down on this bottom one, we might have to cross out a lot more here. Okay? So let's start doing that. There's 1 x, 2 x's, 3, and 4. Okay, now I have no more remaining x's to be able to cancel out or cross out over here. Okay? I have 1 y left down here, so I can cross one of them out, right? Let's look at what I'm left with in the numerator here, I have 1, 2, 3, 4 x's and 1, 2 y's. So I would have x to the fourth, y to the second. Okay, x to the fourth, y to the second. So if we look at this, we might feel a little overwhelmed at first, but if we notice, there's still a pattern that we should be able to see in these problems, right? We have the same base in all of these problems. What does it look like I'm doing with their exponents when I'm dividing like bases? Okay, so that brings us to our rule. When we are dividing powers with the same base, I have a to the nth power over a to the m power. Okay, my bases are the same. It is a to the n minus m. A to the n minus m power. Okay, so if we go back, look at some of these. For instance, I think one of the easier ones to look at is the second one here. I have a to the fifth over a to the third. 5 minus 3 is just 2, so I have a to the second. For this one, I have 4 to the seventh over 4 to the second. 7 minus 2 is just 5, right? We notice this one, we have two different bases. We just worry about one base at a time. So x to the eighth divided by x to the fourth, that would give me x to the fourth. 8 minus 4 is 4. And y to the third over y to the first, 3 minus 1 is 2. Okay, so hopefully we kind of picked up on that. So these are our two big rules when we're multiplying powers with the same base and dividing powers with the same base. Remember, these rules only apply when we have the same base. Okay, that base could be the same number. It could be the same variable. It has to be the same base. Okay, moving on. Now we are going to look at a power to a power and a product to a power. Okay, remember, when we're talking about these powers, we're talking about exponents. Okay, so a power to a power, we have 2 to the second power, parentheses, that's in parentheses, all of that is raised to the fourth power. Okay, so again, we want to write this as repeated multiplication. In this case, 2 to the second power is actually my base. Okay, so I have 2 to the second times 2 to the second times 2 to the second times 2 to the second, right? I'm writing my base 2 to the second times itself 4 times. Okay, what do we notice though? We can still break this down even more here because I have another base raised to another power. So I have 2 to the second that I can break down. So I break all of these individual ones down into 2 times 2. This one's 2 times 2. This one's 2 times 2. This one's 2 times 2. And of course, this one's 2 times 2. What do I notice here? How many 2's do I have here? 1, 2, 3, 4, 5, 6, 7, 8. 2 to the eighth power. 2 to the eighth power. Looking at the next one, I have x to the third all raised to the second power. Again, I'm going to write my initial base, x to the third, out and multiply it by itself 2 times. X to the third times x to the third. Now, I can break each one of these down again into 3 separate times of multiplying itself. Okay, how many x's do I have here? 1, 2, 3, 4, 5, 6. X to the sixth power. Hopefully, we're noticing a little bit of a pattern between these two here. Okay, take a second and see if you can't figure out what y to the fifth all raised to the third power would be. Okay, so for me, what I'm going to do first, I'm going to write it out as a repeated multiplication. I'm going to write my base out times itself 3 times. Y to the fifth times y to the fifth times y to the fifth. And then, of course, I can split those bases up again because now I have a base of just y raised to an exponent of 5. Well, this is going to turn into a lot of y's here. Okay, how many y's do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Y to the 15th power. Okay, hopefully we're noticing our pattern, what our rule might be here, okay, for a power to a power. A rule for a power to a power is if we have a to the n power all raised to the m power, you multiply your exponents. A to the n times m. Okay, so if we go back again and notice, well, 2 to the second all raised to the fourth power, 2 times 4 is just 8. And x to the third all raised to the second power, 3 times 2 is just 6. And 5 to the third here would be 5 times 3, and that's 15. Okay, so power to a power, you can multiply those exponents. Okay, that's our rule. A to the n all raised to the m power is equal to a to the n times m. Okay, let's take a look at product to a power now. Okay, what is a product in math? That's something we should think about when we're looking at these kinds of problems. What does product mean? Product is the answer or the result of a multiplication problem, right? So 2x, this is saying 2 times x, 2x, that's a product. Okay, so we're going to raise 2x to the fourth power. Again, nothing's going to change here. We're going to write it as repeated multiplication. So 2x times itself 4 times. What do I notice I can do here? I can multiply my coefficients, right? 2 times 2 times 2 times 2, right? 2 times 2 times 2 times 2. And I can multiply my x's to get 2 to the fourth times x to the fourth. Well, 2 to the fourth we can just put in our calculator. And that's 16x to the fourth. Okay, 16x to the fourth. So this is almost hinting at our rule right here. You might be able to just take each part of our product to the power that it's being raised to. Okay, so I have x squared y all raised to the fifth power. Okay, again, I'm going to write my base out 5 separate times. Then I'm going to break it down even more, right? Because I still have x in there that's squared. Right? I can break those x's down, break those y's down. What do I notice about? I'm multiplying like bases here, right? So I would end up with x to the 10th, y to the 5th. If we notice, if we're testing our rule that we kind of just made up right here, okay, well, x to the second, 2 times 5 is just 10. And y to the 1 times 5 is just 5. So maybe our rule works there, okay? Looking at the last one, we have negative 3x to the fourth, all raised to the third power, okay? Again, I'm going to write it out as separate bases, negative 3x to the fourth times itself 3 times. I'm going to break that down even more. Okay, negative 3 times negative 3 times negative 3 times x to the fourth 3 times. This would end up giving me negative 3 to the third and x to the fourth to the third. Okay, and I would get negative 27 x to the 12th. So again, notice we took our negative 3 and we raised it to the third power. And we took our x to the fourth and raised it to the third power to give me 12. Because we know how to do a power to a power, right? And we definitely know how to do this. You use your calculator, right? Okay, so let's think about our rule here. Product to a power, I have parentheses a times b, close parentheses, to the n power is going to give me a to the n times b to the n, right? So if we look at our rule back here, x to the second times 5 is x to the 10th, and y to the 1 times 5 is y to the 5th. Okay, so that's kind of the rule we came up with. That ends up being exactly what we're looking for here. Okay, so ab to the n power is equal to a to the n times b to the n. Okay, so these are the rules to review. Okay, power to a power, a to the n all raised to the m power is a to the n times m. Okay, and product to a power is the one we just talked about. If we have a product raised to a power, we have to raise both parts of that product to whatever power we're looking at. Okay. So now we're going to look at simplifying some of these expressions. Okay, so we're going to look at simplifying some exponential expressions. Okay, so when we simplify these expressions, I have x to the 5th times x to the 8th. Well, I have like bases. What do I do when I multiply like bases? Hopefully you guys are saying I add my exponents. 5 plus 8 is 13, x to the 13th. Okay, for number 2, I have 15y to the 15th over 3y to the 12th. Well, there's a couple different things here, right? I have like bases. I have a y. I can just divide 15 and 3, right? Divide the coefficients and subtract the exponents of like bases. 15 divided by 3 is just 5, and 15 minus 12 is 3. So I would have 5y to the third. Okay, so this part right here is that part that I was just talking you guys through. 15 divided by 3 is 5, and y to the 15 minus 12. Remember, I'm subtracting because I have like bases, and I'm dividing them. Okay, so at number 3, I have x to the third all raised to the 5th power. If we notice we're taking a power to a power, if we remember our rule, hopefully we know that we are going to multiply these. X to the 3 times 5. Well, 3 times 5, I hope we all know, is just 15. X to the 15. Okay? These ones are pretty, it really is a matter of trying to figure out which rule we are going to use, and it's a matter of recognizing which one do I need to do. Is this a product to a power? Is this a power to a power? Am I dividing like bases? Am I multiplying like bases? Okay. So looking at number 4, I have 2a to the third power. This is a product to a power. So 2 to the third power and a to the third power. I have to take both of them to the third power. Well, 2 to the third power is just 8, and a to the third is just a to the third. Okay. Sometimes when we have variables raised to the third power, guys, we call that cubed. So this would be like 8a to the third power, or you could call it 8a cubed. Okay. That's our answer for number 4. Now, number 5, we look at number 5, we have xy squared times x cubed y to the 6th. This might look a little confusing to start, but really, all we have to do is find our like bases and figure out what do we do when we multiply like bases. Hopefully, you guys are saying we add their exponents. So I take x times x cubed times y squared times y to the 6th. Here are my like bases of x, okay? And remember, when we multiply like bases, we add their exponents. So I would have x to the 1 plus 3, because there's assumed to be a 1 here, and y to the 2 plus 6, giving me x to the 4th, y to the 8th power. Okay? So these ones really aren't that tricky either, right? We just have to break these down part by part. Remember, multiplication is commutative. What that means is, guys, is it doesn't matter what order we multiply in. That's why we can rewrite it like this. X times x cubed times y squared times y to the 6th. This is the exact same thing as this up here. Okay? So let's look at number 6. Number 6, I have m to the 6th n to the 14th over m n to the 7th. Remember, like bases, when I'm dividing, I subtract their exponents. So I'm going to go ahead and do that. 6m to the 6 minus 1, n to the 14 minus 7. Well, of course, 6 minus 1 is just 5, and 14 minus 7 is just 7. So I have m to the 5th, n to the 7th. Okay, so look at number 7. Again, we have a product to a power here, right? Product to a power. When I do this, I have w to the 4th, and I'm raising that to the 5th power. Remember, we have to raise each part of this product to this power. So I have w to the 4th to the 5th power, and z to the 2nd to the 5th power. And of course, power to a power, I multiply these, so I would have w to the 20th and z to the 10th. Okay, w to the 20th, z to the 10th. Number 8, same kind of thing, right? I have a product that I'm raising to a power. I have to raise each part of this product to this power of 4. So 3 to the 4th times y to the 3rd, all raised to the 4th power. Okay? Well, 3 to the 4th we can put in our calculator and we get 81. Of course, y to the 3rd to the 4th power, power to a power, I multiply. 3 times 4 is 12. 81y to the 12th is my answer for number 8. Okay? Now, number 9, I have 7x cubed times 10x to the 8th. I have like bases of x. Here, again, I can multiply my coefficients. 7 times 10, which gives me, hopefully you all said 70. And I'm multiplying like bases here, so I'm going to add their exponents. Well, 8 plus 3 is just 11. So I'd have 70x to the 11th power. Okay, 70x to the 11th power. Okay, let's look at number 10. Hopefully, number 10, we can take a look at and realize we're going to divide our coefficients, and we have two separate like bases here. So I'd have 32 divided by 4, x to the 12th, or x to the 12 minus 2, because 12 minus 2, and y to the 4 minus 1, giving me 8x to the 10th, y to the 3rd. Okay. Now, number 11 is a little different. We still have a product here. We have 2 squared, x to the 3rd, y to the 4th, all raised to the 2nd power. Okay, I have to raise each part of these products to the 2nd power. So I have 2 squared times 2, x to the 3rd times 2, and y to the 4th times 2. Remember, we're multiplying here because we have a power to a power. And when we have power to a power, we multiply. So I would have 2 to the 4th, x to the 6th, y to the 8th. Well, 2 to the 4th is just 16. So I have 16x to the 6th, y to the 8th. Now for number 12, there's a few things we have to do first. This is kind of a big one. I have 3x squared, all raised to the 3rd, times z to the 8th. 3x squared to the 3rd over 9z to the 5th times z to the 8th over x to the 5th. First thing I want to do here is I want to raise my product parts to this power. So 3 to the 3rd and x squared to the 3rd. So I'm taking my product to a power of this numerator right here. Well, 3 cubed is just 27. So 27x to the 6th. And since I'm multiplying, I can put my numerators together and my denominators together, okay? So I have 27x to the 6th, z to the 8th, right? Because I put my numerators together, over 9x to the 5th, z to the 5th. Now, I can simplify this. 27 divided by 9 is 3. X to the 6th over x to the 5th. 6 minus 5 is x to the 1st. And z to the 8th over z to the 5th is 8 minus 5, z to the 3rd. So I would have 27 divided by 9 is 3. That's where that's coming from. X to the 6th over x to the 5th. 6 minus 5 is 1. That's where this x to the 1 is coming from. And z to the 8th over z to the 5th. 8 minus 5 is z to the 3rd. That's where we're getting that from. Okay? So some of these problems, we got to be able to identify what we need to do first and the different rules that we can use. Here we used a product to a power. We multiplied and combined our numerators and denominators, and then we used our division properties. Here we used a product to a power and a power to a power, right? So the big thing is we got to be able to recognize what we're going to use and when we're going to use it, guys, okay? That is it for today's lesson.